Okay, so tonight's homework, you have packet pages 14 and 15. Remember, after you do it tonight, upload it right to Schoology. It needs to be in by 5 a.m. tomorrow morning. Tomorrow will be our first Everyone remote day. So you'll watch a video posted on Edpuzzle, the Unit 1 Day 4 video on Edpuzzle, and then do the homework. And you can always post questions on the content discussion board. So the warm-up, this is set up nicely for elimination. And maybe we'll get the x's to match up. So we can multiply the top here by 10 and the bottom by 3, because that would get us 30 and negative 30. So we'll have 30x plus 20y equals negative 90. And we'll have negative 30x plus 15y equals negative 15. And we'll go ahead and add those equations together. The x's add to 0. So we get 35y equals negative 105. Dividing by 35, we get y equals negative 3. Maybe we'll sub back into the top one. So we'll have 3x plus 2 times negative 3 is equal to negative 9. So that's 3x minus 6 equals negative 9. We'll add the 6 over. So that's 3x equals negative 3. And divided by 3, we get x is negative 1. So writing that as a point, we have negative 1, negative 3, because remember, that's really what we found is the graph of those two equations where they cross on the xy axis. All right, so looking at our homework, so the first one, you can take out a GCF of negative 5x. You also could have done positive 5x, and that would have worked as well. Set that equal to 0 and solve, and you get x equals 0. Set the x plus 2 equal to 0 and solve, and you get negative 2. In B, we need to get it equal to 0 first, so subtract the 6x over. We're going to multiply to 9, add to negative 6, so that's negative 3 and negative 3. Set those equal to 0 and solve, and we get a x equals 3 happening twice. So because that happens twice, the graph actually bounces at x equals 3. It comes down and just barely hits 3 on the x-axis. Here we have the difference of two perfect squares. Because there's no middle term, think of it as add to 0. So multiply to negative 81, add to 0. So that would be 9 and negative 9. Set them equal to 0 and solve. You get negative 9 and 9. Multiply to 39, add to negative 16. So we need two negatives to make that happen. X minus 13, x minus 3. Set them equal to 0 and solve. You get 13 and you get 3. This first one I chose to do with substitution. I thought that seemed easier because you already have the y by itself. You end up getting 8, sub back in, you get 17. So 8, 17 is our point where the two lines cross. This one seemed like it was set up better for elimination. I chose to get the y's to match up. So I multiplied the first equation by 2. Then when you add the y's, they wipe out, so you get 5x equals 25. Divided by 5, you get x equals 5. Sub back in, and you'll eventually get y is equal to 2. Remember, you can sub the x and the y answers into both equations to check. C was a little bit more challenging. I chose to do elimination, so I got everything in the second equation that had variables over on the left, constants over on the right. That eventually gave us 5x minus y is equal to 4. I brought down the first equation, and I chose to get the y's to match up, multiplying by negative 2. When you added them, you got negative 4x equals 4. Dividing by the negative 4 gave us x equals negative 1. Subbing back in, we end up getting negative 9 for y. All right, so I believe our notes start on page 10. So if you could flip there. So today is going to be a lot of different definitions. We are going to hammer down a lot of the terminology that we will see throughout the year. You'll find that there's blanks within the notes, and those are for you to fill in. So our first thing we're going to talk about is points. A point is a location that is represented by a dot. It actually has no size. And what do we use for its notation? A capital letter. So a set of points that goes in two opposite directions and never ends is a line. So you can fill in line in the blank on your notes. So it seems they have thickness, but actually a line does not have any thickness, just like a point on its own does not have any size. So a line does not have any thickness, but it goes forever in each direction. So there's two ways you could name a line. You could name it with a single lowercase letter. So you might see a line and you might see, say, like L next to it, and they'll call that line L. Or it could be named with two or more points that are on the line. So let's say we had this here, and you can be copying down these pictures I'm drawing right in your notes. Well, how could we name this line? Well, when you name a line, you need 2 points that lie on that line. So for example, AB would work. And because it's a line, our notation we do is we put a little line above it. So if you want to talk about a line, you should be putting the little line on top. But that's not the only way we could name this line, because there's other options of 2 points. We could also name it BC. And we could also name it AC. Now with lines, order does not matter. We could have said BA, we could have said CB, and we could have said CA, and that would all be perfectly fine. Because it goes forever in both directions, the order in which you put those points is not important. Moving down to the bottom, when you have points that are on the same line, they are called collinear. Co means together, like if someone's a co-worker, they work together. So collinear means they're together on the same line. Now, a set of points that extends forever in all directions is considered a plane. So think of like if a floor, if it went forever, that's like a plane, or a ceiling if it goes forever is a plane, or a wall if it were to go up forever. Those would be planes. It has no thickness or edges. We represent it visually as a four-sided shape. So maybe like a parallelogram or a rectangle. But in reality, it's going on forever. So that picture down below that's labeled P, we're saying that's a plane. In a picture, we've got to cut it off somewhere. We can't have it go forever. But really, we're imagining that it extends on forever. So you can name a plane in a couple ways. You could either do a single capital letter, so like they're calling it plane P, or you could name it with at least 3 points. So this could be plane P, and that could be plane ABC. Now any points and lines that are in the same plane, you can fill that in that blank there, are considered coplanar. So on a plane together. Collinear means on a line together, coplanar means on a plane together. So if we also had, say we had DE here for a line DE is coplanar with points A, B, and C, and so forth. And you can imagine if you took like a single sheet of paper, if you could rest it against everything, then those are considered coplanar. All right, moving on to the next page. So different things that we learn this year will have different names to them. A postulate, or sometimes called an axiom, is an accepted statement of fact. So an example of a postulate that we'll talk about this year is parallel lines will never intersect. Okay, if you're in plane geometry, that is just an accepted statement of fact. Parallel lines will not intersect. If something is a theorem, it's something that has to be proven. So we will see a lot of theorems that we will try and prove throughout the year. So like angles in a triangle add up to 180. That's a theorem that can be proven. So here's some examples of postulates. Through any 2 points, there's exactly one line. So through A and B here, I can draw that line and that's it, no other lines. Now it's important to know when we say line in a mathematical sense, it's straight. Okay, anything that's not straight we would call a curve in math class. Okay, there's no such thing as curved lines in math class. If 2 lines intersect, they must intersect at exactly 1 point. Okay, so if you have 2 lines, their intersection would be named by a point, and we know points are labeled with a single capital letter. If you have 2 planes, they would intersect in exactly 1 line. So this is moving down to the bottom half of the page 11 I believe it is. And here's how you can visualize that. Wherever you're watching this, look at the floor and look at a wall and see where do the floor and the wall meet. Well, they meet at an edge. An edge can be represented by a line. So in this picture we have here, our intersection of the 2 planes would be line ST, because they're really going on forever. So here's some diagrams, a 3-dimensional shape it looks like, but the directions will usually say that it's representing some plane. So we want to shade in the plane that contains H, G, and F. So if we have H, G, and F, we're talking about the plane that's on the top here. So we would shade in that part there. Now E, H, and C, we'll notice EH is up here and C is down here. So imagine if we wanted to lay a sheet of paper that goes through H, E, and C at the same time, that plane is actually going to be diagonal. It's going to look like that. And you have to think 3-dimensionally as we're looking at it. So if you had like a cubist shaped thing, it's going diagonally if it's got to contain E, H, and C. And the planes, the 3-dimensional part, is sometimes one of the more difficult things in this unit. All right, if we go to the next page, a segment is a part of a line that consists of 2 endpoints and all points between them. So there's no arrows on a segment. We would call this particular segment segment AB. Now notice the notation above the A and the B, there's no arrows on it. Makes sense because a segment doesn't have arrows on it. So like sides in a triangle would be considered segments because they end. A ray is a part of a line that consists of 1 endpoint and all points in the other direction. So notice here our endpoint is y, and then it goes forever in the direction towards x. So how we notate this, we always put the endpoint first. Even if in our picture it's going from right to left, we always in our notation put the arrow going left to right, and you always put the endpoint first and then the letter that it's going towards. Now, let's say we had like a T here, and we could also call this ray YT. Okay, that would be the same ray. YT and YX are the same ray because it means start at Y and go the direction of that point. So there could be more than one point in that direction, so there could be multiple ways that you name the ray. Opposite rays are 2 rays that are rays that have the same endpoint and are collinear. So if they're collinear, they need to be on the same line. And if they have the same endpoint, their first letters should be the same. So if I told you BA and BC were opposite rays, what that is meaning, so here's BA, BC, if it's an opposite ray, must go the other way and make a straight line. So note that AB and BA would not be opposite rays because they don't have a same endpoint. Okay, a ray, it's important the first letter should be whatever the endpoint is. So let's practice with that a little bit. So we're going to name all the segments. So let's do all the segments that have L. So we could do LP. Now we don't have to name PL because that would just be the same segment. Okay, kind of like lines, order doesn't matter for segments, but it does for rays, because rays you're only going in one direction with the arrow. But segments and lines, you could do LP, PL, same thing. We also could do LQ, and then that would be all of our segments that involved L. The other one we have is PQ. Okay, and we want to make sure we have our notation, the little segment on top. Now rays. Let's do the rays that could start at L. We could start at L and we could go towards P. Well, LQ is not a different ray. So you could have named either LP or LQ, and that would represent a ray starting at L and going to the right. Now, you technically could start at L and go to the left, but we don't have a point for that, so we wouldn't name that. We could start at P and we could go towards L. So that's a different ray. We could start at P and we could go towards Q. That's a different ray. And we could start at Q, and we've got options here. We could start at Q and we could go towards either P or L. So maybe I'll do this under here too. So if you had written LQ instead of LP there, or QL instead of QP there, that would have also been correct. So you had two options. So there's 4 total rays there. And we want to know if, in part C, if LP and PL are opposite rays. Well, LP would be like that, PL would be like that. Notice they don't have the same endpoint, so therefore they are not opposite rays. So we can say no, do not have the same endpoint. So in the bottom there, parallel lines are lines that are coplanar, so that means they're on the same plane, and they do not intersect. Now this next one is sometimes one of the harder definitions of today, skew lines. They are non-coplanar lines that do not intersect. And let's look at an example of skew. Let's say we wanted to find all the lines that were skew with AE. Well, I'm going to trace in green, no, let's do in blue. I'll trace in blue all the ones that would be eliminated. So non-coplanar. So we could eliminate all ones that are on the same plane as AE. Well, AE is part of the front of this, so all those ones would be eliminated. AE is part of maybe the left side, you could think of it as, so all those are eliminated. So those blue ones are eliminated because they're on the same plane as AE. And anything that is parallel would be on the same plane, okay? Because parallel lines are not intersecting on the same plane. So the CG would also be eliminated because that's parallel to AE. You could do a plane that goes diagonally through it. Well, those 4 that are remaining, those would be the skew ones. So skew to AE would be DC, BC, FG, and HG. So if you eliminate all the ones that are parallel to it and on the same plane, any leftovers would be your skew ones. Now, just like lines can be parallel, if we go to the next page, planes can also be parallel. So parallel planes are planes that do not intersect. So think of like the ceiling and the floor. Hopefully, if the structure you're in was built properly, the ceiling and the floor are parallel to one another. And a line and a plane can also be parallel to each other. So if you have like a line somewhere on your floor and your entire ceiling, those can be considered parallel to each other. The line can be parallel to the plane. So we're just going to do a couple examples from this diagram to finish out the video. Name two pairs of parallel planes. So there's lots of different examples, but let's maybe say the top one and the bottom one. Now when you name a plane, you need at least 3 of the letters in the plane. So of G, A, B, and H, we would need to name it, say at least 3 of those. So I'm going to say GAB. And then we would do the bottom one. So we have D, J, I, and C. We would need to name at least 3 of those. And when you name them, you just kind of go around in order. So I'm going to say D, J, I, and we'll leave out the C. If you put the 4th letter in, it's not wrong. Just make sure you're going around in a circle. We could have also done the front and the back, or the left and the right. Those would be fine as well. So name a line that's parallel to DHIJ. So D, so D, H, or sorry, GHIJ. GHIJ is, you can think of it as like the back one. So something that would be parallel to the back would be any of the front ones, because they're not going to intersect. So you could have had AD, you could have BC, you could have AB, or you could have DC. Any of those would be fine because they're not going to intersect that plane. Name a line that's coplanar with AG. So we need another line that's on the same plane as AG. So there's a whole bunch here. AG is right here. So you could do any of the top ones or the left ones. Those would both be on the same plane. So let's just say AD, but there's various answers we could do there. Name a line that is not coplanar with AG. Well, we can pick any of the ones that aren't traced there. Let's maybe do BC. Okay, again, there's a bunch of answers there, but any of those ones that aren't traced. Name 2 planes that intersect at IJ. Well, IJ is this one right here. So basically, you can think of it as like the bottom and the back are the ones that would intersect there. So I'm going to call it JDC for the bottom. And the back, we could do GJI. Okay, you need just 3 of the letters. And name a point that is coplanar with A, D, and G. So here's A, D, and G. So the one to finish out that plane would be J. All right, so you got your homework problems, your day 3 homework problems. Make sure to upload them by 5 a.m. tomorrow, and you'll be working remotely tomorrow.